Welcome back to session 4 of our CENTURO training module. Today we're going to talk about some of the data around CENTURO and how we know it works and different methodologies to test how it works. So we're going to jump in first. I'm going to share some data around leaching, but maybe not the leaching that you're thinking about. So if you recall back to session 2 and a little bit in session 3, we talked about how pronitrogen itself has a slight positive charge, and that slight positive charge allows the active ingredient itself to be adhered in the soil and not as easily leached from the profile. This is a data set proving just that. So what you're looking at is a study that had soil from Illinois, Iowa, and Kansas, and there was 3 different leaching volumes poured down the soil column, and then the amount of active ingredient in each of those columns was measured at the end of the study. And what you see here is that a lot of DCD was leached from the profile compared to that of CENTURO, where very little active ingredient was actually leached. And so again, this is just some data to really kind of define the differences between DCD and pronitrogen in the way that the two stay within the soil profile. Now, shifting gears a little bit, we're going to talk about UAN here for just a second, and then we'll round this conversation out with some anhydrous data. And here is a 2019 study with UAN side dress across Iowa, Nebraska, and North Carolina. And a couple things that I would call out here is you see on the left, we've got untreated, untreated as in no CENTURO and no instinct. As you go from left to right, you see 1.5 gallons per ton to a 2.5 gallon per ton rate of CENTURO, statistically and very much numerically better than the untreated. So again, CENTURO really taking a leap out in front here with some of this yield data. And then as you go to the right-hand side, another call out is we are statistically the same as both a 37 ounce and a 19 ounce per acre rate of instinct 2. And so again, basically the same performance with instinct, slightly better numerically, and then really a big jump up in yield performance from the untreated. And so again, going back to, this corn crop with CENTURO is utilizing more of the nitrogen that you're putting on. I've got this in here as I want to make a quick call out to ATS. So I hear some folks talk about, well, I'm using UAN, I'm putting ATS with it, I should be fine, right? There's a misnomer out there that ATS is functioning somehow as a nitrification stabilizer or nitrogen stabilizer, excuse me. And certainly when you look at it from a chemical perspective, there's the possibility for that to happen. But the problem is you would need so much ATS to create any kind of stabilization that it's certainly economically not viable, and it's definitely not agronomically viable to put that high of a rate of ATS on with your nitrogen. And this is a great study that really kind of illustrates that. And so this study was done by applying a 28005, where that same solution was used across all of these different nitrogen rates. And so as you see here on the bottom of this table, we go from 60 all the way up to 240 pounds per acre of nitrogen. And for those of you that have ever used a blend of UAN and ATS, you know that as you go from 60 to 240, you're also increasing that ATS load per acre. And what I think is really interesting here is that despite the fact that this 240 pound application rate having a lot of ATS in it, we're still seeing a benefit from CENTURO, which tells me that even though this was probably agronomically more sulfur than the treatment really needed, or the corn crop really needed, we still see a benefit from the application of CENTURO. Again, just illustrating the point that even though we're putting on more ATS than we need, it's still not functioning as a nitrogen stabilizer. And as a quick call out here, some of you may be thinking, well, as you add ATS, you've increased the amount of sulfur in these different treatments, and that is 100% accurate. But gypsum was applied to mitigate the sulfur application rates across all treatments, and so that factor was controlled for because all treatments ended up with the same amount of sulfur. So just a quick call out here, some folks say, hey, I've got ATS with it, and the problem there is that it's not economically or agronomically viable to put enough ATS with that UAN to really get any kind of actual stabilization. I think this is a great data set out of Purdue that really illustrates that. Now, I'm going to wrap this up with anhydrous data. So depending on what part of the country you're in, you may make fall applications and you may make spring applications of anhydrous. And I think An important call out here with this data set is that it really doesn't make a lot of difference whether you're putting it on in the fall or in the spring. CENTURO is still going to function and provide a better or higher, a higher nitrogen use efficiency. So this particular data set is 12 different site locations across Nebraska, Illinois, and Missouri. And as you can clearly tell, it didn't really make any difference whether it was fall applied or spring applied. CENTURO is providing a really nice statistical as well as certainly a large numerical advantage to the untreated control. You'll also see we've got a slight numerical advantage to nitropyrin, but statistically we are the same there. And so I think this really just illustrates, regardless of fall or spring applications, either of those two timings can really benefit from CENTURO by nice yield advantages that you see here. So with that, thank you for watching our CENTURO training module. We'll wrap this up with session 4. Appreciate your time, and if you have any questions, please reach out.